Roar! Let's convert rectangular coordinates to polary and polary to rectang. Rectang to polar. Polar to rectang. All right, let's do this, okay? Remember, rectangle coordinates always involve x's and y's, and polar coordinates involves r's, and thetas or angles, okay? All right, so just keep those things in mind. And let the point P have polar coordinates r theta and rectangular coordinates x, y. Duh, I just said that, right? Now, all these facts that we talked about as we started this lesson, it's all here for you. X equals r cosine theta, y equals r sine theta, and we know why that's true. Also, we know why r squared equals x squared plus y squared, because we know that r squared is actually basically the hypotenuse of a right triangle when you actually travel, right? And tangent of theta is y over x. That's no common mystery, right? That's like not a mystery, okay? All right, so whoa, but the instructions may confuse you a little bit, so don't let that throw you off. Given rectangle coordinates of a point, so remember, this is a rectangle coordinate, find two sets of polar coordinates for the point in 0 to 2 pi, okay? So we're given rectangle coordinates, chicos, so don't think too hard like I always warn you about. This lesson is easier than you think. 0, -5. I went 0 to the left and right, but I went down 1, 2, 3, 4, 5. That's it. So let's go rectangle. This is rectangle, an x and a y, but we're gonna go polary. All right. Now you can do it multiple ways. There's multiple right answers. Let me ask you this. Remember, it's r theta, but we do this guy first, right? How much should I turn? You're right. I should turn 3 pi over 2. All right. And how much should I go forward? I should go forward 5. Yay! Okay, but you know, there's people that actually want to go travel, because I feel like this person is traveling more, or rotating more. They want to rotate less. So how about if they wanted to rotate this way, right? So let's travel that way, okay? So we're going to go, this person's going to travel pi over 2, right? Now they're there. Now, how much, now, if they are there, right, if they rotated here, right, I'm sorry, they rotate from here to here, they have to go backward, -5. They have to go backward to get to that point. See if you understand why. Remember, I'm going like this. I'm starting at 0, but I went beep. I'm going beep, 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 right? All right, so I'm going right up. Oh, sorry. This one, you're right. I'm going to have to go forward, okay? Oopsie, because I went beep, 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 but I have to go forward. Because watch, I'm going to do it again. Ready? Beep, 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 bing, 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 5, right? But what if I wanted to go pi over 2 this way? Beep. I have to go forward, right? I mean, I have to go backward, not forward, because then I'll be in the wrong quadrant, right? So I could also go this way. -5, but I have to go pi over 2. So that means I went pi over 2. I'm here, but I got to go back that ass up. All right? So there's, think of another way where we didn't write all the ways, but just write one. Okay? It says find 2 sets of pairs. So we found 3. Ooh, too many, okay? Try the next one on your own. Wait a minute. This is not a very easy one. This says x and a y. Whoa. It doesn't even want to write. This one is x and a y with what the factor? X. Sorry, pencil error. It's because of the way the placement is. Oh my god. X and Y, right? Okay, X and Y. Okay. Now, whoa, that one looks a little bit tricky-dicky. Well, you know what? Don't fret. Why don't you just be normal? Okay? Just be normal. Okay? Why don't we go -3? We know -3 is about -1.73. And then we're going to go down the same amount. So when we actually go to the left and down this much, where do we end up? We end up something like this much, okay? So as you can see, we went -3 left and then down -3, right? So wait, these are congruent. Ooh, okay, so who cares about anything else but the fact that this has to do with the pi over 4, maybe, you know, like anything with 45-degree triangle, right? So you know that this is a congruent triangle here, 45-90 special right triangle. So hopefully that's already registered into you. You know an x and a y, so look at all the information that's given here. Which one's the best for you to use if you're trying to figure out, remember, you're trying to figure out this guy in r theta. So you're trying to figure out the r and the theta. So you can clearly figure out the theta right now by using y over x. Oh my gosh. So you can go first. Oh, this is the first thing you should do. This is second. tangent of theta is equal to y over x, which means I'll be able to figure out the angle right now. So tangent of theta, where is it? Negative root 3 over 3, negative root 3 over 3, which means tangent theta is equal to positive 1. Ask yourself, where is tangent theta? Positive 1. Positive 1. That means I went to the right and up or down, left and down. That means it's going to be pi over 4 or 5 pi, just kidding. 5 pi over 4, yeah, I'm right. 5 pi over 4, right? Because that could be in the first quadrant or the third quadrant. But in our case, what is it? You're right. Our house is this guy here. So we already got the theta. Be excited. We're almost halfway there. Third step, we need to figure out the radius. How do we figure out the radius? Well, we know an x and a y, right? So don't you know that x squared plus y squared equals r squared? Duh, right? Isn't this the radius right here? So all we do is negative root 3 squared plus negative root 3 squared equals r squared, which gives us 3 plus, this is a negative, right? But it doesn't matter because we're squaring it. 3 equals r squared. That means r must be root 6 plus or negative. Plus or negative is kind of important, okay? Plus or negative. You know what? I'm going to write that better because it's so important. Sorry, I try to neglect it, right? Plus or negative, r equals root 6. Why is that important, right? You know what? I'm going to rewrite this again because this is so ugly. Sorry. R is equal to plus or negative root 6. Now, plus or negative 6 is important because we can go forward or backwards. Remember, it's a directed distance, right? So let's conclude. In speaking in polary language, in r theta, we can go we can turn 5 pi over 4 and you go forward, how much? Root 6. Now tell me, what would I do if I was over here? I'm lazy to turn. I'm right here. What do I want to do? You're right. I want to go pi over 4 only, but I want to back that ass up. Back that ass up. So I'm going to go root 6 negative. That's why the plus and negative are there. Can you write some other ways? Of course. What if I want to go boom, boom? Someone could live this way. Someone could live over here somewhere, So they might want to go this way. So what would I do then? Then you would go 3 pi over 4, right? But would you go forward or backwards if I went this way? I spun around that much. I have to go forward, so I have to go root 6. Do you know another way? Find another way? I will have you think about that. But you're right. What if someone's like, you know what? I need to get something from the store and somewhere over here. So I need to go all the way here and then back that ass up. That means I'd have to go. I know this is what you were thinking, right? Maybe you weren't. Did I give you something to think about? 7 pi over 4, but I'm all the way at 7 pi over 4, right? Me, back that ass up. It's like you didn't know math, so you went too far. Okay, but you still got there. And that's the most important thing. So we got those 4, okay? You only needed 2 answers, but we got 4. Hopefully you understand steps 1, 2, and 3. I think sketching is a key, okay? And all this information, you got to have it in your head, but nothing that you don't know already. Let's go here. Now. Remember, this guy, we went rectang, so we were given the x's and y's, and we went to find r theta. But now, what if I give you the polary has given you instructions, and now you have to find the rectang, okay? Given polary, now we have to find the rectang, okay? And you know what's nice? All you need is this right here, this information, ding, 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 okay? All right, so let's go. 3 to pi over 3. Okay, remember, this is your r and this is your theta. Oh, shoot, what happened there? This is your theta. We need the x and y. We need the x and y, okay? We need the x and y. How do we get that, okay? Woo! So we got to use, now some of them you can probably just kind of guess, okay? And I like to think of it this way. 2 pi over 3 is a known special right triangle. It's a 30, 60, 90. 5 pi over 4, that's actually a known triangle too. It involves 45, 45, 90-degree triangle, special right triangle. So if you think about the ratios and how they stay consistent, no matter how large or small a unit circle is, or how large a triangle within the unit circle is, it doesn't matter, right? Because the ratio remains the same. So you know it already. So you know that this is going to involve root 3 over 2 and half. This is going to involve root 2 over 2. Just keep that in mind. And I think most of you guys can probably just figure this out right now. I bet you were thinking, well, I know for sure that this one is going to be short and long, right? Short and long. So maybe you guys already are thinking, we'll verify this, but were you maybe thinking that this is going to be simply half to the left and root 3 over 2? But wait, we have a radius of 3, so it's going to be maybe times 3 times 3. Now we're going to verify that Miss Chang's prediction was correct. Not because she's your teacher, but let's actually achieve this. Because this is for a unit circle, but we have a radius of 3, so we're multiplying by the radius next to it. Same thing with this one. I have a feeling this is going to be root 2 over 2, root 2 over 2, times a radius of 4, times a radius of 4. So if I don't reduce, I'll write 4 root 2 over 2, 4 root 2 over 2. If I do reduce, it's 2 root 2 and 2 root 2. Let's verify these answers by doing step by step. But if you don't need to, you don't need to. I'm happy with that. Remember, x equals r cosine theta, and y is equal to r sine theta. If you forgot that, just go back and look at that and think about how you would achieve that. So I get x is equal to, our radius is 3, cosine of 2 pi over 3. And you know cosine of 2 pi over 3 is negative half. So I'm going to erase that, right? I don't need to write that. It's negative half. And I know that y is equal to 3 sine 2 pi over 3. But I know that sine of 2 pi over 3 is root 3 over 2. Lo and behold, that's our x, and that's our y value there. So if you understand what's really happening, you don't need to do all the math. But if you don't, then it's okay if you follow these instructions, okay? And then you get this. This is your final answer. Now let's do number 2, first step. You're like, x is equal to r cosine theta, y is equal to r sine theta. So here is my radius, here is my theta. So let's try this. X is equal to negative 4 cosine of 5 pi over 4. Now I know that cosine of 5 pi over 4, I'm in the left, the third quadrant, right? So I know it's going to be negative root 2 over 2. I know y is equal to negative 4 sine of 5 pi over 4, but I know the sine of 5 pi over 4 is in the third quadrant, which is negative root 2 over 2. Again, negative root 2 over 2. And what do I get here? Positive 4 root 2 over 2 and positive 4 root 2 over 2, which becomes 2 root 2, 2 root 2. Here is my x and y. Here's my x and y, x and y. See? You take that unit circle value, the ratio that always stays constant, and you just multiply, or you apply the the radius, because the radius length changes, but the ratio is maintained. All right? Hopefully you understand that. Did I go too fast? Make sure you ask me questions as we move along. Why don't you try these two on your own and check your video. Check the video in a second. All right? Okay, welcome back. Now, I'll just write the answers for these, but I'll do a brief sketch too. Bing, 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 270, 1, 2, done. So I bet you got something like 0 and negative 2. And that's the only one that's valuable. And if you sketch it, that's actually pretty, it's pretty, obvious, right? Pretty obvious, that's what it is. 17 pi over 4, holy cow. That means I rotated around the pole how many times? 1, 2, and then I'm left here, first quadrant. I've traveled twice around the world, and I end up here. So I know that it's a pi over 4. That means it's a special right triangle there. So it's going to be root 2 over 2, root 2 over 2. But I have to apply my radius. It's 5 over 2, 5 over 2, and 5 over 2. So I end up with 5 root 2 over 4 x, 5 root 2 over 4 y value. And these are my rectangle coordinates. So here's how you go from polar to rectangle coordinates. Pretty easy if you sketch it, if you try to understand it using common sense, okay? Bye, polar bears!